Welcome to the ultimate guide on prompt engineering. If you've ever felt like an artificial intelligence model isn't giving you the exact answer you want, or perhaps it feels like it is hallucinating details, the problem might not actually be the model itself. It is highly likely that the problem is your prompt. Today, interacting with large language models has evolved from simple chatbots into a highly sophisticated, technical discipline. Prompt engineering is no longer just about typing questions. It is the art and science of structuring inputs to guide AI models toward producing accurate, relevant, and highly reliable outputs in professional environments. Think of it as coding, but instead of using traditional programming languages like Python or C++, you are programming with natural language. Over the next 10 minutes, we will explore everything from the absolute foundational basics to the most advanced, cutting-edge techniques used by top AI researchers in 2026 to build enterprise-grade reasoning engines. Let's start our journey with the most foundational core technique. The absolute simplest method of interacting with a language model is called zero-shot prompting. This is when you ask the model to perform a task without providing any previous examples of what the output should look like. You are relying entirely on the model's vast pre-trained knowledge base. For instance, if you type, "Translate this English sentence into formal French," you are using a zero-shot prompt. It is incredibly effective for simple, standard tasks like basic translation, summarization, or general knowledge retrieval. However, as your tasks become more nuanced, zero-shot prompting often falls short. Because the AI has to guess the specific format, tone, and logical structure you are expecting, it is highly prone to deviation when faced with complex data extraction, mathematical reasoning, or highly specific corporate formatting. When zero-shot fails to deliver the precision you need, the immediate next step is to upgrade to few-shot prompting. This is one of the most reliable ways to improve output quality. Here, you provide a few explicit examples of input-output pairs directly within your prompt to show the model the desired format, style, or logic before giving it the actual task. By seeing a pattern of success, the large language model learns exactly how it should structure its response, which drastically reduces errors and hallucination rates. Think of it as showing a new human employee 2 or 3 perfectly completed reports before asking them to write their own. For example, if you want to classify customer reviews by sentiment, you first provide 2 examples of positive reviews and 2 examples of negative reviews, followed by the final review you want the AI to classify. This establishes a highly rigid template. Another incredibly powerful foundational technique that completely alters how an AI interprets your request is role prompting. Instead of just asking a question into the void, you actively assign a specific persona, profession, or identity to the AI model before giving your instructions. A classic example is starting your prompt with, "Act as a senior software engineer with 20 years of experience in distributed systems." By doing this, you instantly constrain the model's tone, its perspective, and the depth of its response. It steers the AI away from generic, high-level answers and forces it to adopt expert-level vocabulary, prioritize industry best practices, and reason through the problem exactly how a seasoned veteran would. Role prompting fundamentally changes the statistical probability distribution of the words the model selects, aligning the entire output with the simulated expertise of the assigned persona. But what happens when you need a large language model to solve a complex math problem, a tricky logic puzzle, or a multi-step analytical workflow? Standard prompting usually fails because the AI tries to guess the final answer immediately. This is where chain-of-thought prompting comes in. Discovered by researchers at Google, chain of thought is conceptually as simple as adding the phrase, "think step by step," to your prompt. Instead of jumping straight to the final conclusion, which often causes severe hallucinations, the model is forced to explicitly write out its intermediate reasoning. By breaking the problem down and writing out step 1, then step 2, the AI essentially gives itself a scratchpad to think before concluding. This gives the AI time to process the logic, leading to massive, mathematically proven improvements in accuracy on logical, arithmetic, and common-sense reasoning tasks. As AI models have gotten smarter, prompt engineering has moved heavily into advanced structured techniques. One of the most critical breakthroughs for production-grade AI applications is structured prompting using XML tags or markdown headers. By using specific delimiters like context, instructions, input_data, and constraints, you create clear, unambiguous boundaries in your prompt. This helps modern models perfectly distinguish between the background information you're providing, the actual task you want them to execute, and the data they are supposed to process. It is essentially treating your natural language prompt like a well-organized JSON payload or a structured database query. When writing prompts for automated pipelines or enterprise systems, structured prompting guarantees that the AI doesn't accidentally treat your input data as an instruction, vastly improving the reliability of the system in production environments. We also rely heavily on negative prompting. In many scenarios, telling an artificial intelligence exactly what not to do is just as important as telling it what to do. Adding explicit negative constraints like, do not use corporate jargon, do not apologize, do not include introductory text, or do not invent information prevents the model from falling into its default, conversational behaviors. When combined with a constraint-first approach, where you list all of your restrictions at the very top of the prompt, you ensure the model keeps these rules firmly in its attention span before it begins processing the main task. This is absolutely critical for generating programmatic outputs, like forcing an AI to output pure, valid JSON without adding friendly conversational filler like, here is the JSON you requested, at the beginning of the response. Let's push even further into cutting-edge, state-of-the-art methods. Tree of thoughts is a highly advanced evolution of the chain of thought technique. Instead of a single, linear reasoning path where the model just goes from step A to B to C, Tree of Thoughts encourages the model to explore multiple possible solutions or branches simultaneously. The AI generates several different potential approaches to a problem, evaluates the viability of each one, discards the paths that lead to dead ends, and then selects the most promising path forward. This works much like a chess-playing algorithm evaluating thousands of future moves before making a decision. Tree of Thoughts requires a sophisticated prompt framework and often involves multiple AI calls, but it is currently the absolute gold standard for solving the most difficult analytical, creative, and strategic tasks that require deep foresight. To combat hallucinations in mission-critical applications, AI engineers use advanced verification methods like chain of verification and self-consistency. In self-consistency, we don't just ask the model for an answer once. We ask the model to generate multiple different reasoning paths for the exact same problem independently, and then we use majority voting to pick the most common, consistent answer. With chain of verification, we force the model to draft an initial answer, independently generate verification questions to check the facts in that draft, execute those verification checks against its own knowledge, and then output a final, corrected response based on the verification. These highly iterative, self-correcting techniques drastically reduce hallucination rates and make large language models highly reliable for enterprise use cases like medical analysis, legal document review, and financial forecasting. So, what are the absolute best practices for prompt engineering in 2026? First and foremost, treat your prompts as strict programmatic contracts. Define clear objectives, provide clean, structured input data, and enforce exact output formats using examples. Second, practice iterative refinement. You should always start with the shortest, simplest version of your prompt. Run tests, find exactly where the model fails, and add only the specific necessary constraints to fix those specific gaps. A common mistake is writing incredibly long, bloated prompts full of unnecessary details from the very beginning. This often confuses the model's attention mechanism and dilutes the core instruction. Keep your prompts modular, precise, and rigorously tested against a dataset of edge cases. Finally, we must talk about context engineering, which is the new frontier of working with language models. Prompt engineering is no longer just about the text typed into the prompt box, it is about the holistic environment surrounding the AI. How are you dynamically injecting data via retrieval-augmented generation from a vector database? What is the current chat history state? How is the hidden system prompt configured? How are you chunking and formatting the data before the AI ever sees it? Mastering all these architectural elements together, blending traditional prompt engineering with systems architecture and data engineering, is exactly what separates a beginner who just uses ChatGPT from a professional AI engineer building scalable, autonomous AI agents. To wrap up, prompt engineering is an incredibly dynamic, highly structured, and vital technical skill in the modern AI era. By mastering techniques like zero-shot, few-shot, chain of thought, tree of thoughts, and XML structuring, you can unlock the true, unfiltered potential of any AI model on the market. Remember, you must stop talking to artificial intelligence like it is a human conversational partner, and start programming it like the logical reasoning engine it truly is. Thank you for watching this masterclass. Be sure to subscribe to the Tech Space for more deep dives into the absolute cutting edge of software development, artificial intelligence, and technology.